But what if we have higher order of differential equation, not second order? What do we do? Okay, they said that we have the setup of the condition like this. If you take a look at the equation in here, you would find that only the last equation that equal to fx divided by a 0x. The rest of the equation would be equal to 0. If you want to know like how many equations that you should have, if it is the third derivative differential equation, third order differential equation, you would get 3 equations. If it's the fourth order of differential equation, you would get 4 equations. And then the way that it goes, every equation has the first derivative of v1, the first derivative of v2. If it is second order differential equation, you have v1 and v2. But if you have third order differential equation, you would have v3. Okay. Every equation, v1, v2, v3 is going to be in the form of the first derivative. But for your y, the first equation is y. The second equation is the first derivative of y. And the third equation is the third derivative of y, and so on. But you got to keep in mind that your last equation wouldn't be equal to 0. It should be equal to fx divided by a 0x. Just that. Now take a look at the example. Find yp of this differential equation. If you take a look at this, you would see that sec x times tan x. Both functions here is not UC function, right? If UC function is between the form of sine, cosine, or sine. Now, although it's saying that, so you got no choice to use, you cannot use undetermined coefficient method to find yp, because this function is not the UC function. You cannot use shortcut, but you can use the operator method, but you got to see that whether your PD function can be separated into 2 terms. But this one you can't. You see, it's like you got narrow choice to pick up the method to find yp. It seems to me that only best choice for this problem statement is variation of parameter method. Okay, so although the problem statement asking you to find yp only, but with this method, you still need to find yp. If you don't find yp, you don't know how to assume yp. So first, that we got to do is just that find yc. Yc starting with the characteristic equation, which is n squared plus 1 equal to 0. So by this, you would get the root of m is equal to plus minus I. So our yc is equal to z1 cos x plus z2 sin x. From that, we would say that, okay, our y1 is equal to cos x and our y2 is equal to sin x. Then we can assume our yp. Yp is equal to v1 y1 plus v2 y2. Right? Now, we are going to set up the equation. So by this, we would get 2 equations, right? We would get 2 equations, which is y1 times the first derivative of v1 plus y2 times the first derivative of y2 equal to 0. And the second equation is the first derivative of y1 times the first derivative of v1 plus the first derivative of y2 times the first derivative of v2 is equal to fx divided by a0x. But our a0 is equal to 1. So that means it's equal to 6x times 10x. So we are going to set up the principal rules to find the first derivative of v1 and the first derivative of v2. For the first derivative of v1, we would get the determinant of, you see, if comparing to primal rule, this is our c0 and this is c1. You put c0 and c1 into the coefficient of x. But for y, you keep the coefficients of that. So you find determinants of this term dividing by the determinants of the coefficients of your x and y. Now your x is the first derivative of v1 and your y is the first derivative of v2. So you would get this. And then, because you know that your y1 is equal to cos x and your y2 is equal to sin x. Here what they need the first derivative of y1. The first derivative of cos x is equal to minus sin x, and the first derivative of sin x is equal to cos x, and then you just plug the function in there. And then you find the determinant. I hope you guys all know how to find the determinants of 2 by 2 function. So you would get v1, the first derivative of v1 is equal to minus 10 square x. And then you do integral of that, right? Because what do we want? We want v1. What do we get here? We get the first derivative of v1. So in order to get v1, we know that the first derivative of v1 is equal to dv1 by dx. So that means dv1 by dx is equal to minus 10 square x. So you do integral of this, you would get v1, which is equal to x minus 10x. We do the same for v2. Okay? By using primal rules, we would get the first derivative of v2. We replace c0 and c1 to the coefficients of y2, of v2. And then we just plug, the rest is just the same. And then when we find determinants, we would get 10x. And then we do integral of 10x. We would get integral dv2 is equal to integral 10x dx. We would get v2 is equal to minus ln cos x. Now we get both v1 and v2. Then we just plug into our assumption that yp is equal to v1 y1 plus v2 y2. Our v1 is equal to x minus 10x and our v2 is equal to minus ln cos x. And then that we get yp from deviation of variable method.